Welcome to my talk. Talk's called Procedural Content Generation for Entertainment Venue Design. My name is Simon Blakeney. I'm a technical account manager at Epic Games, and the primary part of my role is to help our customers with the technical adoption of the Epic ecosystem. I work across different industries, mainly AEC, but also auto, fashion, and a few M&E customers. And that's my profile page, actually, if you want to see some of the tutorials that I've made in the past. So the following examples are hypothetical designs. They're not structurally sound. I'm not an engineer. I'm not an architect. You may see some really strange things going on with the geometry, but this is a demonstration of how you can use PCG and how you can apply this to perhaps to your own workflows. So to start off, I've created just a brief video showing some of the things that you'll see in this presentation. A couple of things I couldn't include in the presentation. There's 90 slides, so I'm going to be going really quick fire through this. In the top right-hand corner, we've got a data asset. Sometimes you can control your PCG assets from a data asset, and this gives you a lot of flexibility to expose values and control them in a really nice, fluid manner whilst your game is running in real time. I see a lot of people struggle with larger data sets and missed opportunities to instance objects. PCG is hugely powerful, but most of the examples that I've seen are really based around foliage and landscapes and don't really dive into how they can be used in AEC projects. And also, real-time technology could be injected into the design process of AEC projects more thoroughly, I think, and earlier in the design stage, perhaps even at the BIM execution plan. So I've got lots of these drawings as well. I found the tool in PowerPoint, and I've got a bit carried away, but we're going to look through the tactics of this. And I'm going to start off with seating. One of the really powerful aspects of PCG is that you can drive the distribution of objects on a spline. This is just an indicative stadium spline shape, but it could be a cricket ground, it could be a football ground, it could be a theatre, Formula One stands. You've got that flexibility when you use a spline to put it into different configurations. For this project, though, I've started off with the stadium spline, very, very simple. And what I'm going to do is use the spline origin point down here at the edge of the pitch. I'm then going to spawn the seating arrangements in 2 tiers, and then add on extra bits to make it look like a stadium. So floodlights, roof structures, advertising boards, all off of that one spline origin point. And before I go any further, it's just worth mentioning, if you go to fab.com, there are a lot of examples of modular assets that you can download and use as part of a similar process with PCG. So I'd highly recommend going on there and checking what's available. For this project, though, in Blender, I created a few objects. I created an advertising board that you can see at the bottom, a chair that we could distribute hundreds of thousands of times, and also this floodlights. There's no real textures on any of this stuff, but if you have the time, obviously do that because you can get visual fidelity as well as the power of PCG on top of that. It's very important just to check where the pivot location is as well on these objects. For the chair, it's at the base there. And what we're going to start off with is the first step. We're going to start off with one plugin, the Procedural Content Generation Framework plugin. And I'm going to create a blueprint called BP seatline, which is going to communicate with a PCG seatline PCG graph. In the blueprint, we want to add two components. We want to add one spline component, and we want to add one PCG component. The spline is something that we can change at any time later on. It doesn't really matter. Keep it really simple, though. If you're testing, you don't want to have millions of objects. You might as well start off with just a few. So keep it really, really simple there. The PCG is linked to a graph, that graph that we just created, or you can go to the drop-down list and create a new graph from that point. If we switch over to the PCG graph, we're going to start off by sampling the spline data. So the get spline data node, we set this to self, and that's going to pick up that spline that we have as a component in our blueprint. We then want to use a spline sampler to sample on the distance, and this is the width of the seat. So the width of the seat in this scene is 52 units. We've changed the mode to distance. We are then spitting that out into transform points node. And here, this is really useful if you want to make slight tweaks. So my seat, for instance, was the wrong orientation, but the 90-degree rotation there on the last axes allows you just to rotate those seats quickly. And finally, the static mesh spawner, we're setting this to a seat from the mesh entities side. And that will give us our straight line, our first row. But now we want to replicate that onto additional rows. What we need to do is transform this on the Z and the Y axis. So to do this, one easy way to make a loop in PCG is to first go to subgraph. So you right-click in PCG graph, you select subgraph. It's going to say it's missing. You need to create one or just reference to an existing graph that you've just created. In the node itself, sorry, the subgraph itself, we want to create different input pins. We've got a second input pin at the bottom here for a counter. This is going to be the number of rows that we're going to feed it. Firstly, the allowed types, we want to change that to an attribute so that we can control that attribute outside of the subgraph. And also the pin status is really useful just to change that to normal. By default, it's advanced, and you just can't see the pins in the graph until you change that value. The next part we're going to look at is partitioning up the attributes. When we get to this stage, we're going to have a list of points, and they're going to be in different rows. But what we want to do is split those up into different files so we can use it as part of the process for the loop. So every row will then initiate the loop sequence that we're aiming for. And what that looks like is this. So we're inputting the count attribute externally. We're then subtracting 1, so we've got the 0 on the array off. We are then creating points, and we can then duplicate that point by the iterations, which is the counts that we've inputted in. We're then changing the attribute partition, so we're separating that data up, and we're referencing against the index for this. And you can see on the right-hand side, just there, this is separating this out into different arrays for us for each row. The next step is to create another subgraph, and this time it's a loop. So just type in loop. Again, it's going to say it's missing, but we can reference that against an existing creation or a new reference. And in this loop subgraph, what we want to do is we want to filter out by the index. We want to make our transformations from the index, and then we want to push that back out to the static mesh spawner. So what this will do is it will, in sequence, add the X and Y transformations for us. And just going up one level, we've got our 2 loops, we've got our loop counts, and we've got our gen loop there. The first loop, that's the subgraph. We want to feed the out into the in of the loop subgraph. This will then iterate through the number of times that we have on that initial number of rows. And then we want to feed in the data that we're getting from the spline. What that will give us is multiple rows. And if we go a little bit further and we start to introduce curves into this, you'll notice that there's a really big problem here. We're fine on the distance subdivision at the very bottom row. That's the 52 units that we referenced before. But the further we replicate out on that spline, the bigger the distance will be, the bigger the gap will be. What we need to do is we need to resample. So here on the left-hand side, we have our original curve spline. We have the distribution of the points. But now we want to add reference against the points we have on each row, and then create an additional spline, and then sample that spline as well. And it looks like this. So we have our original graph. We have the transform points. We're then creating another spline from those points. We're sampling again with the same values. So that's the 52 units interval. We're transforming if we want to. We don't have to, but we might find that useful if we've got some rotation problems there. And then we're feeding that through to the static mesh spawner. So that gives you this result. It's really clean results, but we have these problems on the right-hand edge, or depending on the shape of the spline, you might have them in different areas. We can fix this by going back into the spline sampler and just ticking the box for fit to curve, which will correct for this. And this is just a quick animation showing how far we've got so far with this process. And you'll see that I'm right-clicking and going to the spline generation shapes tool, which is very, very useful if you want to set up stadium curves or other bits and pieces. Here we've got the radius, the degrees, and the branch right or left options. And very quickly we can get that curve in place. Nanite's instances view is very, very helpful. If you are running through a PCG graph and you're coming across different bugs and maybe the chairs or the objects you're working on are not appearing in the place that you expect them to be, check the instances on the Nanite view because you'll see flickering effects if you have overlaps on any of those. That's a really good debugging method. Also, it's really worth looking at the execute on GPU option on the static mesh spawner. This will free up some of the resources that you have on the CPU and pass those over to the GPU. You can also do this on the copy points node. I know that a lot of people use a lot of copy points nodes in their projects, so that should be a good one. And generally speaking, when you start off in a PCG project, it's really worth testing the numbers. What I typically do is I'll set up a create grid in PCG and just spawn maybe 2 million instances or all the different things that you might expect to have a performance reducement. Just test them out first on various exercises. Next, I'm going to move on to stadium pieces. Again, in Blender, I created some really rough and ready models of various stadium aspects. We've got a facade on the left-hand side, the outer skin of the stadium, some random arrangements of structural forms. I know that they don't work, so please don't. And corporate boxes and various other bits and pieces there. So these are the two structural components. Just make sure everything's Nanite enabled as well if you can, just for flexibility, especially if you're working at high iteration speed on projects. It's going to save a lot of time. This is a quick image of some of those structural components in place. Again, everything is spawned on that original spline, but you just offset in a different position. And if you know what the pivot location is from that original position, it's really easy to manipulate these sorts of things very, very rapidly. And you'll notice that I've got skin on this as well. So I've got a skin of glass on the top and the outer skin of the stadium here. I've approached it in a slightly different way. This is using a spline mesh spawner. It deforms the mesh as it goes around. So you need to make sure that the triangulation of those particular pieces are higher so you don't get any artifacts around the edges. Lighting. We've got the floodlights here, but a really nice feature of PCG that I don't really see being used a great deal is the fact that you can spawn actors. Here I've selected a spotlight, and if you select the template actor class and you select the allow template actor editing checkbox, what this allows you to do is to open up the template actor settings, and you're able to then change all manner of aspects of that particular actor. So in this particular case, it will be the intensity values, the radius, all the settings that you would typically set up for a single light source. You have that flexibility. Megalights, if you haven't got it turned on, it's really useful in these circumstances, especially if you're trying to spawn thousands of lights. It doesn't really make sense to have this off. As an additional extra, I've set up some material parameter collections. I know this isn't PCG, but people seem to miss this. If you set up a material parameter collection and you set up some scalar parameters or vector parameters, you can then link those into your materials and you can control them externally. And it's just a really nice way to link values. But I'll show a little bit later where that's also useful. With that, with the lighting, we've got the day lighting for the stadium, and we've got the night lighting for the stadium. And that's really easy to spawn. You can just link that to a data asset, have that as a little toggle, and then spawn the lights on as and when you need them. Going back to the spline, this is just another example of that in action. Now that we have all of the structural components in place, again, I'm using the spline generation shapes just for a shortcut. And here I'm changing the radius to 3000. When you close the window, that's when it initiates the tool. I wanted to see how far this could go, but I got bored. I tried to be patient, but I couldn't. This is quite a big area. There was no real performance decrease on this. I did have another example where it was going on for miles, but yeah. It's a bit tedious to test, but it's very, very flexible in those regards. Another little tip, if you're not aware, but if you want to add third-person content to navigation to your scene, just go to the Add button, go to Add Feature or Content Pack, select third person, and then in the world settings, change your game mode override to third person, and then you can have a third-person character. Here, I've just run the PCG spawn process in runtime. It doesn't really drop on the frame rate. I'm recording this with OBS as well. It doesn't really drop on the frame rate until the seats come in there, and it drops a little bit. But generally speaking, it's super fast. And this is going to show another version of that. You can change the ordering sequence as well in PCG, the execution dependencies. So you could have something spawn in, and then you wait for that to spawn, and you continue the process with other parts. The next thing I wanted to mention was the remote control API. This is a really incredibly useful plugin that's used in virtual production. What it allows you to do is to create a small interface where you can expose any of the values that you have in Unreal Engine outwards to a little UI. And that UI can be driven as well on a web interface with a Node.js server. So from my iPhone that you can see on the right-hand side there, I've exposed various values from the data asset that I've linked into the PCG. I can also add other things, though. So let's say we've got the sun sky that isn't part of the PCG process. We can expose those values to the remote control API. And then we have this really nice interface where we don't have to go through 50 different menus to set up our scene. We can do this very, very rapidly whilst it's running in runtime as well. So if you're doing a design review for an architectural project, for instance, you might want to have somebody driving this, an architect perhaps driving this in the background, and you might want to have a really simple way for them to do that rather than for them to know how to use all the complexities of Unreal Engine UI. Populating crowds. Unfortunately, I didn't have enough time to go as thoroughly through this as I wanted to, but since we have our spawn seat in locations, we can just drive that through to another transform point if we need that, or we can just drive it through to a static mesh spawner, and that can give us our character distributions. These are just static meshes at the moment, but if you're using VATs, vertex animation textures, you can reference those as well. So just make sure that you have LODs on each of the VATs on each of the LODs to be able to get the right crunching of data as you're moving through the scene. And just a quick video just to show the speed of that as well. Again, because of the approach, it doesn't have any impact really on the performance at all. Just let it run through. Interactive seating. So a fantastic addition to PCG is the Instance Actors Interop plugin. I've not seen too many people use this so far, but what it allows you to do is, let's imagine you have 10,000 seats that you've spawned, and you've spawned those as ISMs or HISMs, or the instances. But then you have a player, and you want your player to interact with a seat. What we can do is use the Instance Actors Interop plugin, so that when the player comes into a certain proximity to the seat, it switches that over to a blueprint. That blueprint can contain anything you want, really. What I've done for this particular example, though, that I'll show you in a minute, is I've added a camera for each of the blueprints, and I've added a small interaction with a sphere collision. So as the player gets really close to that chair, you can press E, and then that player can sit in the chair. I haven't added the animations, but you could make that really nice. The same could apply with doorways. It could apply with light sources, any sort of interaction. It could be metadata. So we had a chat about that the other day. There's loads of ways that you could start to explore this. So to set this up, what you can do is just make sure that you have the Instance Actors plugin enabled, the Instance Actors Interop plugin enabled. We then want to go to the Instance Actors part of the project settings. And we're looking for this Instance Actors class settings string here. What we then need to do is go to the data registry and link to the folder where we'll reference our blueprints that will utilize the Instance Actors Interop. We then create a then create a data table, and with that data table, we need to make sure that the row name is referencing against our blueprints, but we need an underscore and a C as the suffix for that to work. Also, if you look here, if you select that row, we can turn off shadows. We can do various things with the blueprint that's going to spawn. And then the node to initiate that is the spawn instance actors node. And we're just linking to our blueprint on the actor class there. Then going back onto the PCG graph, all I've done here is spawned out from the seating into the Instance Actors Interop spawn instant actors node. Wow, that's a mouthful. And then on the blueprints, I've added a cine camera, just a text render, and a sphere collision, and a bit of code in the background just to initiate that. It's not a great example. You can do a much better job than I did. You could get the character to initiate an animation and do all sorts of things. So it's hugely powerful, I think, there. Another edge case is line of sight analysis. What we've introduced into PCG is the ability to cast rays, so line traces in Unreal. And the way that you can do that is I've created an array of points here. We've got a static mesh spawner, which is just spawning some seat locations. I've got transform points, if you need it, and a world raycast node. So on the node raycast node, we want to change the origin input attributes to position, and then it's really important to change the ray direction as well. So we're changing the ray direction for the orientation of the character in the seat. So it's a slightly raised offset transform from the seat's origin point that it's referenced against. And I've got a debug node in here as well, just so that we can view that. So here, you can see that I'm changing the ray directions. I'm going through, I'm changing the height, and you can see that as that ray is firing out, it's firing towards the objects in the distance. If I move this and replay the debug, you can see that if it hasn't hit anything, then it returns back to its original location. So we can start to think of using these sorts of tools for line of sight analysis for, say, view corridors, or it could be that you have digital advertising in venues and you want to check where you might be able to have the best exposure of a particular bit of advertising. It could be that you have broadcast cameras that are set up in particular positions. It could be that you have line of sight analysis from every single seat stadium, and you want to see if anything interacts with any sort of production setup. An event lighting. So another really cool thing that you can do with PCG is you can start to link this in with other tools within Unreal Engine, and one of those is DMX. So here, what I've done is enabled the DMX engine, DMX fixtures, DMX protocol, control console, and pixel mapping. You could use the DMX template as a starting position if you wanted to. But what DMX does, is it's a communication protocol which can link in with light sources. If these lights that we have in this room, if they were hooked up to a DMX universe, we can control those from Unreal Engine. We can control the rotation. We can control any of the exposed values. But then we can feed that into PCG as well. So if we're working on some sort of esports arena or a theater space, and we want to just have a bit more control over where those light sources are designed, that's another way that we can utilize PCG. So here I've got the BP laser module, and you'll find this in the fixtures DMX plugin. If you go to the engine plugins content in your content browser, you'll find it in engine plugins DMX fixtures laser folder. So here we've got a DMX component in this particular blueprint, which won't be referenced. So we need to re-reference that afterwards. You can also load from data tables in PCG. So here I've loaded just a simple array, but I've also tested this with the stadium that we had. On the attribute mapping, we've got the XYZ values. And when you spawn your light sources into the scene, what we need to do is repatch those up. If you go to the DMX template, you'll notice that there's a DMX lib fixtures library that exists in library, and a fixtures patch for laser modules. If we select all of those once they've spawned from PCG and then just address those the same, it means that all of the animations that you've put in the sequencer will relay back onto the laser modules correctly. So this is just a quick example of what that can look like. I've not animated it, but you could just go in the sequencer, change the exposed values, and then you've got a really nice setup there. And I've got through this incredibly fast. I didn't think I would get through this as fast as I did. So I'm on the summary. Hugely powerful feature in Unreal Engine, PCG. There's lots of things that I didn't cover, and I probably should have now. Data assets being one of them. That gives you a lot of control that you can then link into the remote control API. You've also got the geometry interop, geometry script interop. You've got Niagara interop. So there's lots of ways that you can flex these graphs in different directions going forwards. So with that, it's shorter than I expected, but thank you very much.